Hello, my name is Fabio Oliveira. Welcome to one more tutorial. At this time, we will see classification of images with CNN, convolutional neural networks, using Huawei ExceML. ExceML is a service provided by ModelArts. It's the process of automating model design, parameter, tuning and training, and model compression and deployment with the labeled data. The process is free of coding and does not require your experience in model development, enabling you to start from scratch. This lab guides you to image classification of flowers. Image classification is based on image content labeling, and the image classification model can predict a label corresponding to an image, and is applicable to scenarios in which image classes are obvious. Before starting, you need to sign in an account with Huawei Cloud in this website that you see in your screen, huaweicloud.com. Once you did that, you will need to set up as well a key for accessing the Huawei Cloud Storage service. Okay? You can find this information once you connected for the first time in the platform. Additionally, you can download the dataset data labeling for flower recognition on this link provided. Once downloaded, make sure that you name it the folder, and it will be easier for you to link and upload the image to the model on Huawei Cloud environment. With no further ado, let's go to the action now. Hello students, once you created your account on Huawei Cloud, log in, sign in, and then once you sign in, you will see this page. Once in this page, go to Console, click on Console, I will change the idiom to English for obvious reasons. Now, you go in the left side top menu. In Storage, you go for Object Storage Service. Select. Once selected, you are in the Object Storage Service environment. Now, you go to the top right, click in Create Bucket. This will create a folder inside the cloud storage environment. You give a name to the bucket. I will give mine. You leave all the options as standard it is. You don't need to change anything. And then click Create Now. Okay. Once created, you will click or access the new bucket, clicking direct on it. Once you are inside the bucket, you will see an option in the left menu of Objects. Click on it. And now we will create a new folder inside the bucket. Give a name to the folder. Click OK. Once it is created, we can start uploading the image that you have now downloaded in your computer, following the instructions of your handbook. Click in there. And then now you click in Upload Object and drag your files where it is instructing you to do, as I am doing now. Click in Upload. And now let's wait to complete. You can follow the progress of uploading on this bar on the bottom of the page. Once it's completed, I'll be back with you. Okay, we are back. You can see that we successfully completed the upload of 42 out 50 images for some reason. Maybe sometimes the internet connection fails, something like that. But don't worry, with 42 we'll be able to build the model. Once the upload is done, you come back there in Overview again, come back to the storage service again, in Object Storage Service, and we need to create another empty bucket that will be used by the model to download all the predictions and the classification of the model. You go again here in Create Bucket, create another one. I will create one named Output Flower. He doesn't like capital letters. That's fine. I just create now. I will leave it as it is in standard mode. Oh, the name already exists. Create another one. Okay, we will use these two buckets. The first one with the objects we created, we uploaded, and the second one for the output of the model. Once we finish that, come back to the menu on the left, and now scroll to the Enterprise Intelligence and click on ModelArts. Once we are in ModelArts, you go again in the menu on the left and click ExceML, which is the environment where we have the pre-built models for image classification, object detection, predictive analytics, sound classification, and text classification. Let's see image classification. We create a new project. I'll give you a name to the project. You can give any names you want. You can add any description you may want. And I will specify the input data, which will be inside the flowers. I just create the first one, and I will choose the folder where the images are. Click OK. In the output dataset, you will refer to the empty bucket we created, output, for the outputs. Okay. And now we create the model. You can see here now that we need to label our data. You can see that we have all the data unlabeled here, the 42 images, which now we need to create and label. This label tasking is very intensive and manually done. In this environment of Huawei's ML, ExceML, we can do it easily and quick. I'm not an specialist in flowers. I will create some categories and some labels. If I got it wrong, please forgive me. How do we create the labels? The first thing, let us choose the image you want to label. I will label first category as Daisy. Okay? So what I will do, I will choose the pictures that are Daisy flowers category. Let's do that together. So let's click in the daisies ones. The one is one. No, don't need to click on them, just in the box here. Let's do another daisy here. Another one here. Another one here. Let's go to page 2. Another one here. More. Let's keep doing that. Now I have 7 selected images. I will input the name of the label and click in OK. And then you see the image just move it to the labeled category. Okay, let's keep doing this now. We'll do a few roses now. page 2. And let's label rows. The image will be transferred. I think I did something that needs to be completed. Rows again. Oh, we have rows, unlabeled rows here. Now let's label tulips. We still have daisies here. Let's choose them. One more here. Go. Nearly finishing. I have one more rows here. We have more tulips here as well. And we have now dandelions. That's right here, dandelions. Need to choose them. Dandelions, okay. And we have here another days. Another days. And the last category will be sunflowers. Sunflower. Okay. Once it's done, let's see. Everything is labeled already. We can see that we have the labels under each one of the images. Very nicely done. Yes, you did that without any coding, without any extra software. Now we can go for training the model. Just click here in train the model. We can see here that the train button is not available yet. The reason is because each class needs to have at least 5 images. Therefore, we just have 4 here. What we need to do is, obviously, or we delete this category, which I don't want to do, or we upload another picture of sunflowers for this category. What I will do now? To do that, you can come here in Unlabeled, and we can add images. So let's do that, add images, and I go for my directory where I have the images, the data sets, flower recognition, and I will choose more sunflowers. Got one here, another one here, another here, another here. That will be enough. Okay. Once uploaded, we need to label them. Okay, now we have the image. Let's label them as sunflowers. It's done. Now we have the training button already activated. Exciting, huh? So let's start training the model now. Just clicking train. Now we have some parameters to be defined. Okay, I will explain it for you. The first one, dataset version. Our first version is there. This is important because if the model does not perform well, you know the version of the dataset you are using. Here we have the ratio for the training and validation sets, which means that the model will split our dataset in 2 portions. The first one for training and the second one for validation, which means that the model will be presented during training with 8% of the image, and then once it trained, the model will be presented with 20% of the image as being new for the model to check the generalization capacity of the model. In other words, if the model is able to recognize correctly new images of flowers in the categories that we just created. We have as well the incremental training version. We can select the version with the highest precision to perform training again. This accelerates model convergence and improves training precision. I will leave it is. We can define the maximum training time of the model. It is in minutes here. If the training process is not completed within the maximum training duration, it is forcibly stopped. You are advised to enter larger value to prevent forcible stopping during training, which will, jeopardize the results. I will leave as 1 hour because I think with these few images, only 4 is more than enough. Then we have the training preference of the model, which means training preference, the value can be accuracy first, long training time. It's here in balance. I will change for accuracy first because I want the model to be very good at it. And then you have the instance factor, which means you use free GPU or you can use compute intensive one instance GPU, which is a paid service. I will use free GPU. Then you need to agree with the proceedings, terms and conditions. You can read later. Said that, with no further ado, we can go for next. Once done that, you can check your configurations. It's all set, all right. We'll go for submit. And the model will start training. Let the model keep training and I will return in a few minutes. Hello students, we are back. As you can see, the model finished the training and we achieved a very high accuracy for a data set with a few images, 82% of accuracy. You can see here in the right the evaluation box with some metrics, which I will explain which one for you now. The first one is recall, which means that among all the samples labeled as a certain class, the proportion of correctly predicted samples, which reflects the ability of this model to identify positive samples. It achieved 79, nearly 8%. And then we have the precision. The precision is among all the samples predicted by the model as a certain class, the proportion of correctly predicted samples reflects the ability of the model to identify negative samples, and it achieved 84%, better than the recall. We have the accuracy. Among all samples, the proportion of correctly predicted samples reflects the overall recognition ability of the model, which achieved 81, nearly 82%, which is reflected here, is rounded up. And we have a new F1 score. This is a metric that are being used by data scientists in general and machine learning, deep learning engineers. It is a combination of all the others, okay? It's a harmonic average of the precision and recall of a model. It is used to evaluate a model as well. When the F1 score is high, the model is good. We can see here that it achieved 81% as well. The training was fast. You can see that was less than 15 minutes. And now what we can do is deploy the model. You can see here in this box that we have the option of deploy service. What that means, after the model training is completed, you can deploy a version with the ideal precision and in the successful status as a service. To do so, you click in deploy in the version manager pane, as you can see here. of the Train Model tab page. After the deployment is successful, you can choose Service Deployment, Real-Time Service to view the deployment services. And we can test after the model is deployed. As a service, you can upload an image to test the service. I will do that now with you. So we'll click in Deploy the model right here, where the model is completed. Let's change for Compute. I will choose Compute Intensive Instance 1. And I will choose here Auto Stop 1 hour later. What that means? It's because then the model will start deployment after 1 hour you started. Meaning that if you forget to switch off the engine, they will not keep billing you. Otherwise, Huawei would keep billing you 1.20 yens an hour. Let's click Next now and Submit. As you could see, the free version is not available, maybe for this region. The model is in deployment. Once it's finished, I will return with you. Hello, we are back with the model already deployed, as you can see, and now it is running, which means we can upload new pictures to the model to make a prediction. Let's do that now. I will upload the picture. Let's choose this one, open, and ask the model to predict. It takes a little bit. Yeah, it's done. So the model says that it's a probability of 53% to be a tulip, 15% of be rose, and 12% of be sunflowers. Yes? Let's try another one. Upload another picture, and this time rose. Let's ask the model to predict and wait. Here we go, 68% of chances to be rose, 12 tulips, and less than 1% to be dandelions. That's it, students. Our model is ready. I will stop now the running, therefore I will not be charged. And this was about building an image recognition model using ML, ExceML from Huawei ModelArts. I hope you enjoy it and see you in the next session.